Now let's solve one question to know the code for segment tree. Now we have a question of dynamic range sum queries. In this question, we'll be working with an array of n integers, and our task is to process q queries of the following type. First one is the update the value of position k to u, and second one is what is the sum of the values in range a to b inclusive. So the input which will be given to us would be the first input line has two integers n and q, the number of values and queries. The second line has n integers, okay, and finally there are q lines describing the queries. Each line has three integers. All right, this one is for the first query and this one is for the second query. All right, now let's start coding it. Now first let me write down all the inputs. I'm declaring an array to store all the elements first. All right, now let me declare one segment tree which will be just an array of size, as I told you, for n, and let me also define long. All right, now first, as we have taken the array, we will first build our segment tree. So build segment tree. For this, first we would need three things. First is the segment tree index, node index. Second one would be our leftmost index and the rightmost index of that node specifically. So we will pass it to a build function. All right, segment tree. Now the first index I'm taking as 1, so that the left index I can take as 2 into index and the right one as 2 into index plus 1. So I'm passing the left and the right one. Now let's write the build function. So it will be a void because I'm just building it. I don't need any return thing. Let me just copy this. Okay, now idx is the segment tree index, segment node index, and L and R. All right, now if I am reaching the root of the node of the segment tree, then at that moment L will be equal to R. So at that time, what I'll do is I'll just write that segment tree value, segment tree node value, as the element itself, which is array of index L. All right, and then I will just return it. Now, like we do in divide and conquer, I'll just simply pass build recursively with array segment tree and the leftmost index, which is 2 into index, and 1 mid, and the second one would be from mid plus 1 to R, and the index would be 2 into index plus 1 of the segment tree node. So 2 into index plus 1, mid plus 1, and comma R, and I will just return this. Right, and now I also need to update the intermediate node value, and that would be after I return from the left recursive call and the right recursive call, I will update my segment tree index value as my segment tree, the leftmost segment tree value plus the rightmost segment tree value. So that would be segment tree 2 into index and segment tree 2 into index plus 1. All right, now that we have built our segment tree, now what we need to do is we just need to process the queries. So I'm gonna input all the queries T A B. So, and I'm gonna cin query type A and B. Now if my query type is 1, that means it is an update query. So I'll just call an update function. In update function also, I will call this like I called build, because obviously I'm updating on the root of the segment tree, sorry, on the leaf of the segment tree. So on the leaf of the segment tree, I will update the value and propagate it and back propagate it through all the intermediate nodes as well. So for that, what I will do is I'll pass a and b value, and I don't need the array, right? Yes. So segment tree I'll pass the very first root node index of the segment tree, and the left node index and the rightmost index. All right. And else, if my query is of query type 2, then I will just output a sum query. Okay. And that is also a function that I will complete. Let me just call it first. Right. Okay. Now let's first write the update query function. Now this is also a void type of function. In this I will pass a, b, and yes, segment tree, and also idx l r. Okay, so in this what I told you guys, that if we are at the very leaf of the segment tree, then we need to update that index, right? So for the leaf of the segment tree, we do this condition, and if that leaf is also our index that we want to update, then we will just update the entry of the segment tree as this. Alright, and we will return. Now similar to what we did in build, we will call either left or right. So in build, we as we were building, we called both the recursive calls. Here we need to check from the root where we need to go. So for that, we need to either go to the left subtree or the right subtree. So for that, I'll just check if my index is less than equal to mid, then I'll go to right. I'll go to left. So go to left, else I will go to right. Go to right. Okay, so I'll just recursively call the update again. Segment tree, my index of segment tree, and mid. All right, and I'll copy this, and similarly I'll call the rightmost recursive call, mid plus 1 and r, right? And when I have updated either the left or the right, then I need to update my current node also. So update my current node. How will I do that? I will just copy this and paste this, right? Okay, now I'm done with my update code, and my first query will be working. Now let me write the second query function, which is the sum function, and I am outputting value. So the return type would be ll, and this is the function. I'll pass the range and this complete thing. All right, now in sum also, we have to we will be coming up with 3 conditions. So we will be coming up with 3 conditions. Either the segment tree node which we are standing, suppose its range is itself a comma b that we want. Okay, this is the first condition. Second condition would be that our range that we want would be belonging to either the left part of the segment tree or the right subtree. All right, and the third condition would be okay, so let me write the second condition first. So either the left or right, and the third condition would be that we are having our calls partially. So half, like some bit of it would be on the left side, and some part of our sum would be on the right side. So let me give you an example. If my current nodes range is from, suppose, index 1 to 10, and I am asking it so suppose 1 to 10, right? So our mid, what would be what it would be, it would be 5. So now my left will contain from 1 to 5, and my right would be having from 6 to 10, right? So now if I want to call, I want my, suppose my A is equal to, suppose 4, and my B is equal to, alright, 6. My right would be from 6 to 10, and my B is from 4 to 8. So half of the call I will call on the left, and half of the call I will call on right. So I need to handle that also. So that is the third case. Alright, so let me write it. The first condition would be satisfied by how? If A is equal to L and my B is equal to R, then I will just simply return my segment tree index, my segment tree index value. Okay, and now for the second one, first I will calculate the mid. Alright, now if my A is greater than equal to L and my B is less than equal to mid, that means I'm just having my complete range that I want the sum for in the left subtree. So I will just call the left subtree simply segment tree 2 into index comma 1 comma mid, and if my this one, if my A is greater than equal to mid plus 1 and B is less than equal to R, then my range lies on the right side. So I'll just call the right side. So index plus 1 comma R, right. Mid plus 1 comma R. All right. So now for the third condition, what I will do is, as I told, that some proportion of my answer would be lying on the left side and some proportion of my answer would be lying on the right side. So I'll call so the mid is basically the split of my a comma b. So if I want to, so the condition is like this, that a comma b I'm calling. So here I will first call till a comma mid, and for the right one I will call from mid plus 1 to R. So for that, in that case, in like I will be returned the answer for my complete range if I add them both. So let me call that return sum. I will call from A to mid segment tree 2 into index 1 mid plus sum mid plus 1 B segment tree 2 into index plus 1 and from mid plus 1 comma R. All right, so I guess this is how we make our segment tree. Now let me run some test case on this, which is provided here, and we'll submit the code also. Okay, so error is coming on line 60, segment tree. Seg fault. Coming here that I should have taken this as L from L to R, and here also from L to R, right? Any place else that I have written 1? Okay, this one also, and over here as well. All right, yeah, so answer is coming as 14 to 11, and answer should be 14 to 11. So let me just download this code and submit it, and let's see if our code is correct. And it's correct. So that is how you solve a question using segment tree. Thank you guys, and keep watching my YouTube channel for more videos on algorithms and various computer science topics. Thank you.